everything I just said. Okay? Everybody cool? All right. Let us go on to the work I assigned you yesterday. Solving rational equations. Now, please be aware that rational equations are math. Understand? But when you learn the math, you can then use that math in real life situations. Okay? So there's no point going on to real life physics questions with rational equations if we don't know how to do rational equations. Yeah? All right. Now, please remember, I did say I was going to give you guys a couple of questions on 132 to 135. Okay? All this stuff is practicable. It all works together, right? So if we go on, we do a bit of a lesson. The last 10 minutes, I give you 2 questions. We'll call it even. Okay? I will really forget what happened yesterday, not pretend to forget what happened yesterday like I was doing for laughs earlier. Okay? Okay. So, we went over... No, we didn't. I just talked to a few people about these. So, probably let's talk about... Well, we could talk about the very first 2, but the very first 2 have an easy trick that if you've been paying attention in math class, you should know. If I do this for you, who remembers how to solve that? I know you do. Who remembers how to solve that question from like grade 8? Cross multiply, right? It's not really cross multiplying, but that's what every teacher calls it. What would you do there? To punch that into your calculator, how would you solve it? 14 times 3, then what do you do with the 27? Divided by 27, yes? And that would give you x, agreed? Now, if you don't believe me, which of course many of you don't, if we were to do algebra on this, we would need to get x by itself, yes? Right? So we would multiply this side by 3, which means what do we got to do to this side? Times by 3, which is 3 over 1, isn't it? Right? Which would give me 3 times 14. Remember how we had 14 times 3? Okay? So that would give me, they'd cancel, and I would have x equals 42 over 27, yes? Now, can't have 27 there. Multiply both sides by 27. 27x would equal 42. Then my last step would be to divide by 27, right? So that cross multiply is just a shortcut to all this algebra. Everybody cool? Everyone remembers seeing this with the cross at some point in their lives, yes? Especially if they were in a class with me. Everybody good? All right, now, look at what you have here. Isn't that the exact same thing as 3 over x equals 14 over 27? Isn't that fraction equals fraction? Isn't this fraction equals fraction? So can I cross multiply? So 2 times 3 is 6. 6 equals x squared plus x, yes? So x squared plus x minus 6 equals 0, yes? And x squared plus x minus 6, if I factor that, x plus 3, x minus 2. So x had to be negative 3 and positive 2, right? Everybody good? That's if you remember that crossing move. What if you don't? If you don't remember that crossing move, then you got to find common denominators and do all the work. Will you get the same answer? Of course you will. Everybody cool? Could I do the crossing thing here? Yes. Could I do the crossing thing here? No. Here I got to do all my work. Everybody good? Everybody good? Okay. So I'm going to, I think it is 10:01. I do want to give you a couple of questions on your own. Or, yeah. So I'm going to put up a key to this later today, possibly in this block. All right? But the new stuff we're doing works on all this anyway. Okay? So let's flip to page 138. And everybody's biggest nightmare after fractions, word problems. You guys are smart kids. We're at the end of this unit, right? So far this unit, we've simplified rational expressions. We've added and divided rational expressions. We've multiplied and divided rational expressions. Then we added and subtracted rational expressions. Then we did rational equations. So what does all that logically lead up to? A process that will do all of that stuff. Okay? All right? Now, to do a word problem, if you have been in my class in the past, especially in grade 10, you already know, the 4 steps you need to solve every word problem. If you don't believe me, I could show you because I have it right here. Wrong block. Right here. Word problems. You have all, if you've been in my grade 10 class, seen that. And all word problems follow the same thing. You got to do 4 things if you want to solve these. That is too small. Let's make it bigger. Yeah, that's the stuff. You got to do 4 things, okay? Step 1. Assign variables. Because you can't do math until you know what it is you are working with. So, assigning a variable, this means 2 things. Decide what you're counting. You have to decide what your goal is. And give a variable to all things counted. Okay? Everybody cool? Step 2. Write an equation. Okay? Step 3, solve the equation. And step 4, apply your answer from 3 to see if it works. Now, the reason I haven't shown you how to do any of that is because you already know how to do all of that. You may think you don't, but after one question, you're going to be like, oh yeah, I remember this. I know how to do this stuff. I got this. This is no problem. All right? So let's start with a nice, easy one. Tim takes 4 hours to paint a room. Bob takes 3 hours to paint the same room. How long will it take if they work together? Now, somebody always says 7 hours. Always. I'm stopping that now because they always say 7 hours because they see 3, 4, and together. 7! How can it take longer for 2 people to work together on the same job? Okay, so let's get that out of our heads right now. Yeah? Okay. So, step 1, assign our variables. We're only counting one thing here, aren't we? What is the one thing that we are counting? Time. Excellent. So I need a variable for time. I've decided on what I'm counting, and I need a variable for it. Yes? Okay. What are we counting time in? Hours. Excellent. Okay. So Tim, my man Tim, will take how long to paint the room? 4. Are we going to say T for time? Is everybody okay with that? Excellent. How long will it take my man Bob to paint the room? 3 of those same hours. Yes? Is everybody cool? Okay. Well, I know how long it will take Tim to do the job 4 times. Yes? But what is 1 unit of Tim's time? How do I figure out this? How do I know what 1 unit is? 4t equals... Okay, I'll change the question. Tim will take 4 T's to do how much of the job? The whole job, right? How many rooms are they painting, Burke? 1. So 4 T's will do 1 room, yes? What about Bob? 3 T's will do 1 room, yes? Everyone agree? Okay. Solve this. How much is 1 T? For Tim. What math do you do to solve that? Pardon me? Right. T equals 1/4 for Tim. Everybody cool? What is it for Bob? Everybody's good? Right? So if they're going to work together, I need the amount of time that Tim is going to work. Tim plus Bob will equal how many rooms painted? 1. Right? Because we're counting time. Yeah? Well, what was Tim's time? 1/4 T, right? Because we don't know his time. What was Bob's time? 1/3 T will equal how many rooms painted? 1. Do we like this notation? Does this notation right here look like what we've been working on? Little. Except we wouldn't have 1/4 T. What would we have? Oh, so close. T over 4. And what would this guy be? And how many rooms will they paint? 1 room. Can you guys solve that? Does this now look like something we have been doing? Okay, what would you do? Because this is about as easy as it gets. What would you do to solve this? What do I need here? Which is what? 12. Excellent. So this whole thing is going to be over 12, isn't it? What did this guy have? What does he need? He needs the 3. So this becomes what? 3t. What does this guy have? What does he need? 4. So that becomes what? 4t. What did this guy have? 1. What does he need? He needs 12. So what's that going to be? What's 12 times 1? 12. What do I get to do with the denominator once I have it common and sorted? Do I need it anymore? No, because where's the math happening? In the numerator. So do I need this? So all I have to do is solve 3t plus 4t equals 12. Right? 7t equals 12. T equals 7/12. Does that make sense? Oh, sorry, 12/7. Dummy head. 12/7. Does that make sense? 12 sevenths is 1 5/7, right? 1 hour and a bit. Does that make sense? That working together, they would take 1 hour and a bit. So are we okay? Now, stop for a second and think about this. Does this make sense? It makes sense to me. Does it make sense to you? Why did this fraction become this? Why did I have to have 3t and 4t is 12? Because if they're doing this by themselves, right? Tim's going to paint 3 rooms, and Bob's going to paint 4 rooms in the same amount of time, aren't they? But I can't add those fractions. I got it. If they were painting 12 rooms, this is how it would work out. Is everyone okay with this? Tim is working at a fraction. Bob is working at a fraction because they're only painting 1 room. Everybody cool? So the question becomes, how much can they paint of that room in 1 unit of time? Right? If Tim was painting this room, in 1 hour he'd get 1 wall painted, right? 4 walls. Everybody cool? That's how it works, right? Okay, let's look at the second one and see if we can apply this to our new situation. James completes a paper route in 40 minutes. Jeff does the same route in 50 minutes. How long if they're going to work together? So what am I counting in? Minutes. And what am I counting? I'm counting time, yes? So I need a variable, right? T equals time. Is everybody cool with that? Now I have to compare them at the same amount, right? In 1 unit of time, how much will James complete? 40t or t divided by 40? T over 40, right? Because 40 times t, it would be how long it would take him to do 40 routes, right? So James is t over 40. What does that make Jeff? T over 50. Everybody cool? Because we're only counting 1 route. Now we know that they're going to work together, yes? So in reality, it's James plus Jeff to complete how many routes? 1 paper route. So what's James's time? T over what? 40. What's Jeff's time? To complete 1 route. What's my common denominator? What's the common denominator between 40 and 50? 200. So that needs what? How do I get from 40 to 200? Times by 50? 5. So what's this? What's James's? 5t. Plus, what's Jeff's? 4t. Equals what? 200 over 200, right? Because that's the 1. 200 is going to write twice now, because I forgot I'd written it. Now, does everybody understand this, what has happened here? Because this is 5t over 200 plus 4t over 200 equals 200 over 200, right? T over 40, t over 50, and 1. Does everyone see it? Great. Where's the only math happening now? Do we need those 200s? No, because when we're adding fractions, we don't add the denominator, do we? 7 halves plus 5 halves is 12 halves, yeah? So we only care about up top, so we're only going to do this math. What is it? 9t equals 200. So what does t equal? 200 over 9. right? Which is what? What would I do with that? Because that's not a number, right? How long is this class? 200 over 9. How many of you would be happy if I told you, when's the bell going to ring? In 200 over 9. Would that help? No. So what should I do with that number? You could divide it and you would get a number. What would you get? 22.2 minutes. Now, check, does it make sense? James takes 40 minutes to do it all by himself. If somebody helps him, should it take more or less time? Less. Does it take less? So does this answer make sense? Everybody good? Those are easy because of one variable, yes? Okay, turn the page over. See if you guys can do this third one, because it's still one variable. Read the question, see if you can figure it out. Is this the same question or is it slightly different? Do you feel I wrote that question? I absolutely wrote this question. Have I had a girlfriend ask me to help her mow the lawn? This one's a little bit different though, isn't it? So talk to your neighbor for a second, see if you can figure out the slight difference here. What do I know here that I didn't know in the previous two questions?
How long is the total?
I know their total, don't I? I know that Kyra plus the boyfriend equals what? 24 minutes. Agreed? Now, do I know Kyra's time? What is it? 40. So how many? T over 40. So I know Kyra is T over 40, don't I? Do I know the boyfriend's time? T over X, correct? Because I don't know. The question is, how long is it going to take the boyfriend? So how do I take what I know and put it into what I have to do? What's Kyra's time? T over 40. What's the boyfriend's time? T over X. And what does it equal? 24? How many lawns are they mowing? 1. Picking up what I'm putting down? This was time, right? Which allowed me to do this, right? Everybody cool? But this is now time plus time to equal 1 lawn mowed, yeah? All right, so how am I going to solve this? Mr. Myers, I don't get how to solve that. I got too many variables. But you do know how to solve this. I need a common denominator. What is it? 40x. What does that guy have? The 40. So what does he need? X. So I got tx. What's that guy have? So what's he need? Plus 40t. 40t equals what? What does that guy need? Both of them, right? So what does he get? 40x. Is everybody cool? Now where do I do my math? I just need to worry about the top, yes? Now, I've got t's and x's. Do I know one of those numbers? I know t, don't I? Why do I know t's? Because total's 24 minutes, isn't it? And I only want to know how long it's going to take Mark. Or not Mark, the boyfriend. The boyfriend is x, right? So since I know t is 24, what can I do now? Plug it in. What's 24x plus 40 times 24 equals what? 40x. So 24x plus, what's 40 times 24? 960 equals 40x. What will I do? What does 960 equal? Right, 960 equals 16x. So what does x equal? $60, not 16, 60. So how long does it take the boyfriend to mow the lawn? 60 minutes. Does everybody see why? Now, the question that one has to ask oneself is it the math or is it the setup? It's the setup that's causing you problems, right? If something's going to cause you problems here, it's the setup, right? But the setup, everything we need is in the question, isn't it? Okay? So, let's now go to a real life question, even though it's obviously a joke the way I've written it. So read the question. So we got a whole bunch of information in there, don't we? Right? When he sails towards Langley, is the current pushing him or against him? If you don't know anything about geography, you're in trouble here, aren't you? The river flows towards the ocean, yes? Is Langley that way? Is Langley between us and the ocean? Okay. Right. So when he goes to Langley, is the current helping him or hurting him? The current is flowing towards Langley. I am paddling towards Langley.
Oh yeah, it's helping.
The current is helping him.
Yeah.
So there would be Jamie plus the current. Correct? Everyone agree? That's when he goes away. What about when he comes home? So what will this be? Will it be a plus or a minus? Minus the current when he comes home. Does everyone agree? What else do we know about this? Pardon me? I've got a time right there. And what else do I have? So I've got a time of 9 hours. And what else do I know? A distance of how far? 24. Okay. Do I know any other knowledge here? What else do I have? I have the speed of the current. Equals 2 kmh. And what am I trying to find? What do I not know? It's the only thing I don't know. I don't know Jamie's speed. So what is the only thing that needs a variable? Jamie's speed. What should I give it? Does it matter? Let's call it S. Everybody cool with that? That's all the information, right? Right? Okay. So, I know I have to worry about distance. I know I have to worry about away and home. What's the distance that he traveled away? 24 kilometers. What's the distance he traveled home? 24 kilometers. Everybody cool with that? I also knew the speed. What's his speed going away? We've done it right here. It's Jamie's speed plus the current, yes? S plus what? 2. What's his speed coming home? S minus 2. Look at how smart you are. What else do we know? We know the time. How long did the whole trip take? 9. I'm going to just move something here. $48. And what's this? $48. That should be what? Okay. What do we know about times when we have distances and speeds? Because this is a real life problem, right? Obviously, I wrote it in a jokey way, but it's a real life problem. What do I know about distances and speeds? You guys have all seen that internet thing where the guy asks his girlfriend, we've been driving for 2 hours at 80 kilometers an hour. How far have we driven? You guys haven't seen that? Really? That was a funny thing. The guy's got a super hot girlfriend, and he says, we've been driving for, it's in America, so we've been driving 60 miles an hour for the last 2 hours. How far have we gone? How far have they gone? Huh? 120 miles, right? Because if you go 60 miles an hour, you drive for 2 hours, you go 120 miles. The girl can't figure it out. And she gets really angry at him. And he filmed it with his cell phone. Have you seen it? So what do we know about distances and speeds? Are they related? What is it? How are they related? I'm going to slide over here off the page because I don't want to get in the way.
So he's going at 2 kilometers an hour with his curve's going 2 kilometers an hour, so he's doing 9 hours.
So we know something about distances and speeds, don't we? What is speed? How do we measure speed? You guys have all got your licenses or your learners or your Ns. You know what speeds are. How do we measure speeds? km divided by hours, yes? What's kilometers? A distance, a time, or a speed? A distance. That's a distance. What's hours? Time. So that must mean that speed equals distance divided by time, correct? All those strokes that are disappearing are going to show up at the bottom as soon as I do this. So, knowing what you know now, what does that tell us? That's just a class list. I'd like, in a perfect world, notebook would reopen. In a perfect world, notebook would reopen. So I could continue with my lesson. There it is. So speed equals distance over time, correct? Everyone agrees? Does that tell us anything else? Does that tell us what time equals? What? Distance over what? Speed. Does that tell us what distance equals? Speed times time, right? How does that help us over here? Well, first of all, it disappears down to the bottom of the page because, you know. And then your computer freezes. How does it help us? Where do we need to fill in that chart? What are we trying to find? We need to find times, don't we? So, what do we know? We have a distance and we have a speed. So, can we fill in times? How? What is time equal? Oh, for Christ's sake. Right. And what is the other time? 24 over s plus 2 and 24 over s minus 2, correct? And when I add up that time, how long does the whole trip take? 9 hours. So what's the equation that I know? You do know that when the two of you ask me how to do the next question, I'm not going to help either of you, right? Okay, just making sure. Continue your conversation. I don't want you to stop because I know how important it is. I just want you to be aware that I am watching and I am listening. Okay, just making sure that's out there. So, what do I know about these two times and that total time? They're not the same. You've got to add them. 24 over s plus 2 plus 24 over s minus 2 has to equal 9 hours, doesn't it? Do you know how to solve that? Great, solve it. What do I have to do? Common denominator. Okay, what is it? Right. So my common denominator is, s plus 2, s minus 2. What does this guy need? S minus 2. So what's that? 24s minus, 48. Plus, what's this guy need? So what's that? What's that? 24s plus 48, right? And what's this guy need? The whole thing, which is s squared minus 4, isn't it? Not plus 4. Right? So what does that equal? 9s squared minus 36, yeah? Do I need any of those denominators now? Yes or no? No. So I'm going to get rid of them. And what would I do with all that red? Combine like terms and then what? And then what? Once you have it simplified, are you going to be able to find s? S. And once we have s, don't we know what our answer is? Go. Oh, because I got to pee. I need a key. Ooh, I'm a poet, and I don't even know it. Solve that, and I'll BRB. Oh, another rhyme. All the time.
Minus Don't forget, it's not S squared plus 40S
minus 36 minus. No, you stopped. You factored in that number for the S.
Why would
Holy, I had to stop in the cooking room. They're making cookies. And there's a bunch of little kids in there. What the hell is that about?
It's just a kindergarten class.
They're kindergartners?
Yeah.
I love kindergarten.
We're making skillet cookies.
Damn. All right. Did you guys get this solved while I was admiring cookies? What is it? 9s squared minus 24 and 24 is 48. So minus 48s. And the 48s drop out, minus 36 equals 0, yes? And then what would we do with that? Factor it. Okay, what's coming out? 3. So we're going to have 3s squared. We don't care about the 3, do we? Or do we? Three s squared minus 16s minus 12 equals 0. Now what? It's 3 times negative 12 is negative 36, right? So it's got to add up to that. So it's 18 and 2, right? And then I got to divide them by 3, right? S minus 6 and 3s, that's a 2. 3s plus 2? Plus 2 equals 0, yes? Do I know how to solve that? What is s now? Oh, 3 can stay there, it's fine. What is s now? For this to equal 0, s has to be 6 or what? Negative 2/3. Oh man, I've been given 2 answers. So what's the one? What do I have to check now? Which one makes sense, right? S is Jamie's speed, correct? Is it possible to paddle at a negative speed? So is this a possible answer? No. So what's the speed he paddles at? That's checking for common sense. Everybody cool? What? What? No, because Jamie's speed was just S. Right? What he did was 6 kilometers an hour. On the way there, the current helped him. So he got 8 kilometers an hour. So it took him 3 hours to get there, right? On the way home, he still paddled at 6, but he lost 2 kilometers an hour. So he was only at a net speed of 4 kilometers an hour, right? So 6 hours to get home. 3 to get there, 6 home, 9 hours. All right, now see if you can do a physics question right here. Since it's a physics question, we're going to have distance, speed, and time, yes? Everyone agrees? So, we've got a distance. We've got a distance. We've got a speed. And we've got a time, yes? So, the distance, and we have halfway through, his speed is slowed down. So I have how many stages of his speed? 2. There's part 1, part 2, and of course we have a total, don't we? What is his distance for the first part of the race? Read the question, talk to your neighbor if you need to. 70, excellent. What is his distance for the second part of the race? 70, obviously, for a total of 140 miles. Everybody cool with that? Everyone's cool? Okay. What was his speed in the first part of the race? Do we know it? So if we don't know something in math, what do? We give it a variable. What would be a good variable for speed? S. Lovely. What happened in the second part of the race to his speed? He lost 6 miles per hour, yes? So whatever speed he was going, he lost 6 miles per hour of that. How do I say that in math? S minus 6, correct? We can't do his total speed because the speed changed, right? Okay. What is time always? Distance over speed, right? So what is the time here? 70 over S. What is the time here? Over S minus 6. What's the total time it took to run the race? But what do you guys feel about fractions? 8.5. Everybody cool? So now what do we know? What are we trying to find? We need to find S, right? So what do we know about where is the spot that we have everything filled in? We have everything we need. Which row? No, because distances, there's no unknowns. Here, there's no total, so it has to be here, yes? So how do I write this as a math equation? 70 over S plus 70 equals what? 8.5. Can we solve that? How? What's my common denominator? S and S minus 6, correct? So what does this guy need? S minus 6. S minus 6. So what is that really? 70S minus 420, right? Everybody cool? What's this guy need? That guy just needs S. So plus 70S, correct? Is everyone still agreeing? Everybody is still following along? What does this guy need? He needs s squared plus 6s, doesn't he? So what does it equal? 8.5 s squared plus 51, 1s. Is everybody cool to there? Is everyone cool to there? Okay, now what should I do with this mess? Simplify. So 8.5 s squared. What's 70 and 70? 140. And when I move it over here, it's going to be what? Oh, this should have been minus, right? This is s minus 6. Sorry. So when I move that positive 140 over here, what does it become? This is positive 140s. When it moves over here, what does it become? So I'm going to have negative 191s, yes? And what happens to this negative 420? And what does all that have to equal? Do we have a way to solve for s when it's ugly like this? Huh? Quadratic formula. What? You're bringing that back from Unit 3, Mr. Myers? Why I oughta. But you do. Because that's how the world works. When you do that, what do you think's going to happen? How many answers is it going to give us? How many answers does it always give us? 2, right? It's going to give us 2 roots. So I'm going to help you guys out because we're running out of time. We'll quad formula it, and we end up with 2 different numbers. We end up with s equals 2.47 and 20. Which one is the right answer? Cole? Pardon? 20. Why? He'd be pedaling backwards there. Is the wind strong enough to blow him backwards? No, or he never would have finished the race. So it has to be 20. Does everybody understand? Okay? So please notice we're getting into a bit of crossover with physics here, right? If you've taken physics, this shouldn't be news to you. Right? So remember, we're always looking at fractions because it's rational expressions, right? We're trying to complete whole things. I want to give you one warning. No, I'm going to not give you a warning. Ah! So you guys try 140, just 140 for homework tonight, 4 questions. And it's 10:50, we don't have time to do a little quiz. I will trust you that you are not being chumpy. So do 4 questions for homework tonight. No, I was angry yesterday, remember?
No, I thought you said you didn't have time to do it.
I didn't, but then you guys made me angry in the first block.